So today we're going to be learning about double angle formulas. Double angle formulas stem from our sum and difference formulas, and you will be able to, I will give you these at the top of your test, so you do not need to memorize them, but it will be helpful to memorize. Okay, so basically a double angle formula is what is sine of 2 theta or cosine of 2 theta. So how do we get these formulas? Where do they come from? Well, they're really stemming from our sum formulas. So let's pretend this is A and this is B, and same thing for sine. So in our case, A and B are just the same. They're both x. But in sine of A plus B, what happens is we always take sine of A. So in this case, our A is x. And then we have sine, it's sine A cosine B, so cosine of x again. And then plus, we have cosine of A, or cosine of x, times sine B, which also is x. So again, this is just coming from our sine of A plus B sum and difference formulas. You can be using what you had from last time. So if that's the case, what we end up getting is, by the commutative property, this is just sine x cosine x plus sine x cosine x. It's just the same thing twice. And so what do we get? We get 2 sine x cosine x. So really, sine of 2x is just 2 sine x cosine x. So things become a lot easier, and we can just rewrite it in this way. This helps a lot too when we're taking derivatives, which we won't be talking about as much until second semester or when you're in calculus. So the same could be true for cosine. So for cosine, the sum formula is going to be the easier one. So it's cosine x times cosine x. Really b. And then we change the sign, minus sine x times sine x. So again, where is this coming from? Well, we can clean this up slightly. So this becomes cosine squared x minus sine squared x. And we can write this in this way. So this is going to be one of the ones we use. So cosine squared x minus sine squared x. That's a formula that I will give you. Now I'm going to give you this one on the test. The other two you have to generate yourself. So since we know that cosine squared x plus sine squared x is equal to 1, we can just use substitution to get some other ones. So instead of cosine x, we can say that cosine x is equal to 1 minus sine squared x by just manipulating the previous equation and subtracting sine squared x from both sides. So what happens is we can then substitute. This becomes 1 minus sine squared x minus sine squared x. So another way of writing this is just 1 minus 2 sine squared x. So that's going to be another one that we use very often. And then by the same token, we could do the same thing, but just substitute in for our cosine squared. So we'll get cosine squared x minus, and then sine is also 1 minus cosine squared x. Just don't forget to double distribute here. So this ends up making it a plus, so this becomes 2 cosine squared x minus 1. Now, it doesn't really matter which one you choose to use, but again, I just want to show you there are 3 different ones. On the test, when I give you the formulas, I will give you cosine squared x minus sine squared x equals cosine 2x, so I will give you this first one. If you need to use the other two, then you will need to figure out how to use those. Okay, so the nice thing about double angle is it's really not hard. We're doing a lot of the same things we've already been doing, and it goes back to drawing a picture. So if we know that sine of theta equals 3/5 and lies in quadrant 2, so we want to draw a picture. So we're in quadrant 2, so make sure we're drawing this properly. Theta is here, and we have opposite over hypotenuse. By knowing our Pythagorean triples, we know this side has to be 4, and it must be negative because x is negative in that second quadrant. So if we know we want to find sine of 2 theta, we know sine of 2 theta is equal to 2 cosine theta sine theta, or 2 sine theta cosine theta. It doesn't matter the order because of commutative property. So we're going to take 2, and what is cosine of theta? Well, cosine is going to be adjacent over hypotenuse, so we're going to get negative 4/5. And sine of theta was already given to us, but it's opposite over hypotenuse. And so we really get 2 times negative 4/5 times 3/5. And so when we just multiply across, remember this is imaginarily over 1. So 2 times negative 4 is negative 8, times 3 is negative 24. And 1 times 5 is 25. So really sine of 2 theta for this particular picture is going to be negative 24 over 25. When I look at B, I can use the same picture. The only difference is now I'm going to choose which one I want to use. So again, it doesn't matter which one you use. I'm going to choose the second one just because I don't want to use both cosine and sine. So I'm just going to do that cosine 2 theta is going to be 1 minus 2 sine squared theta. But again, or sine squared x, but theta in this case. You can choose whichever one you want to use. Again, it doesn't matter. You will get the same answer regardless. So I'll do 1 minus 2 times, well, we know sine squared theta, I honestly don't even need to use my picture because I was already given it in the problem. So 3/5 squared, because remember, sine squared theta is equal to sine of theta whole quantity squared. So I can just write it like this, and then don't forget order of operations. So 1 minus 2 times, first I need to do exponents. So 3/5 squared is going to be 9/25. And then we get 1 minus 18/25. And then remember, 1 is really 25 over 25. And when I subtract 18/25, I do get 7/25. And that would be my answer there. You will get the same answer regardless of what version of cosine 2 theta you used. Okay, so a challenge. I really do want you to pause the video and try it on your own because I honestly think that you can totally do it, but I want to make sure that you have it in your notes. So sine of x plus sine of 2x. So the first thing you probably want to do now that we know our double angle formula is rewrite this as 2 sine x cosine x, and then I still have sine x equal to 0. So when you see this, the first thing you should think of is I want to solve for x, but right now there's a lot going on. But what I do know is I see both terms listed have sine of x in common, and that's when GCF comes into play. So I can get sine of x is the GCF, and I'm left with 1 plus 2 cosine of x. And now I'm just solving an equation like I normally would. So I would get sine of x equals 0 and 1 plus 2 cosine x equals 0. So cosine of x is negative 1/2. Watch your algebra here, especially if you're doing it really fast like I just did. Cosine is negative in the second and third quadrants, and at pi over 3 is 1/2. So 2 pi over 3 and 4 pi over 3. Here I didn't give you a domain restriction, so technically I should say from 0 to 2 pi. And then here, sine of x, where is my y value 0? That's going to be at 0 pi and 2 pi. So I end up having 5 solutions. And that's it. So in class, what I want you to work on is the practice. It'll have some review problems and then some 26-6.